Hello, this is Sean on CDT, CTO and founder of Image Dental Studio and DigiSmile from Silicon Valley, California. Today, we will be going over the inLab Software 15 with the emphasis on implant restorations. Let's take you and your laboratory to the next level with Software 15, creating solutions with easier production options as it did for me and my laboratory. Thank you for joining me. Let's get it started. Here's today's webinar agenda. We will be going over administration, scanning with scan body, multi-unit screw retained bridges, design with and without Gingiva functions, milling in CAM software, and material options. So here's what you will need. INEOS X5 scanner, MCX5 mill, inLab Software 15, and scan post per your case on multi-unit abutments, implant level models, and rubber glove. Here we are on main screen. We're going to add a case and we're going to put doctor information, patient informations. The case information is going to be all on 6 and technician names. So on administration's screen, it is very important that we start from bridge restorations. We click on implant, biogenetic of individual, and we're going to utilize gingiva function on this particular case. And we're going to cover without gingiva functions later today. So implants are on 6 implants, 3, 5, 7, 10, 12, and 14. We're going to click on Pontics as well. And implant connection, I choose on multi-unit abutment cemented on anti-trading, and this particular implant size was 800 M. And it comes with the cap size as well, and they're paired as default. So very similar as every other case, we're putting the implant information on each implant restorations. We scan it for scan post, and we choose the milling device, and we're going to choose material as PMMA on this case. So we're going to move on to scanning now. So one of the main difference on screw retained bridge cases, new category called scan body upper. So I like to scan body upper first, and we're gonna use capture area, and we're gonna start scanning without gingivas in place. So one of the very good options with the new software 15 is that we could communicate with the software utilizing arch form. We call it correcting jawline. So we could nail it into perfect arch form so that scanner also knows automatically proper arches are. And I click OK. So we're scanning the upper jaw without gingiva in place. And as soon as this is ready, I'll be going to place scan body on each implant. And software will actually apply different lighting levels on every angulations of implant scan body. So I check, model seems very good. Some final checking. So now we have new options. It says capture scan body on the left hand side, and we click on here, and we're placing the scan body on top of it. And I also have to double click at job positions to capture scan body. So you see my finger, I'm wearing glove and screwing down the scan body on number 3 spot. Firmly finger tight. And whenever I do this, I like to zoom in the model and move my cursor. And double click here. Right there. And as you notice, the scanner moves every direction and shoots different levels of lighting and capturing scan body from different angulations. And each scan body scanning takes about 2 to 3 minutes. So we have to do this one by one. So let's say this case has a 6 implants on. So this would take about good 20 to 25 minutes of scanning whole thing. And one of the unique thing it does is that whenever I click on capture scan body, INEOS X5 makes the model stand up for 90-degree angle so that I could place the scan body very easily. It goes into the stand up motions. So I'm going on second scan body on number 5 spot, and I double click on the spot again. And as soon as I double click on the site, scanner will start positioning the implant scan body into the center and start shooting different levels of light and shooting the scans. It starts from lingual surface with different lightings, and it moves about 20-degree angle. So in order for us to save some times, after second scan body is done, I'm gonna fast forward into upper jaw. So we did up to 5 scans, and now I'm placing the 6th scan body. So now I'm gonna place, unscrew the scan body, and I'm gonna place gingiva into the model, as you see on the camera. And I click on upper jaw. Make sure one more time everything looks good. I'm going to do capture jaw, and I'm gonna do capture reduced for upper jaw with scan body in place. And we just make sure the upper jaw and the scan body upper will stitch together perfectly. So that looks very good. So it is stitching very well. So I'm gonna go ahead and move on to the model. On this particular case, I'm not scanning the lower because I didn't want to be limited towards the occlusal model, but only really focus on screw retain designing. Very nice. Whenever I don't see big difference on two models, I know they're perfectly stitched. So I'm gonna go ahead and move on to the model. So on the model, um, it goes automatically into model editing. So we like to make sure, most of my cases, I like to soften the gingiva area. So it does, meal comes out very fine on gingiva adapting area. And I'm softening it because I'm not covering up to that portion, that area. So we're gonna set the model axis over here, which is very important. In the past, I did make a lot of mistake by setting my arch like this way, but we need to make sure it shows up to the length of restoration will be up to this line, such as if I was putting the teeth in there, about, let's say my teeth will be, my number 8 will be about this length, then I need to create the model arch up to that height. And also this area as well. So I'm moving into edit jawline, which software comes out very nicely for me. I like to fine tune. Be more like that. So we're moving on to click scan body head. So software is marking for number 14. So I go roughly on the center and double click. And move on to number 12. Number 10. And click number 7. And I noticed compared to software tie-based kit scan body, it is different. As long as I roughly click on it, it is okay because software is measuring really on a cylinder area all over to determine the position of implant. So I don't really have to be so precise clicking right in the middle, but roughly just clicking and letting software know where they belong. And all the six implants are marked. And draw margin is because of the gingiva function. I'm basically creating the gingiva margin line. So I basically want to cover up to here. And it's almost as if we're marking the pontic line. And I'm drawing the margin line of the ideal for me. Make sure everything looks good and smooth. And we move on to insertion axis. On the insertion axis, in my experience, I like to leave it not so straight, but show a little bit more of the facial. It had to do, in my experience, with the milling quality. Whenever I tilt the model a little bit, it gives me better milling quality, especially on the facial. So I would leave it like about, this is more straight, but I will leave it a little bit more this way. Here's my helpful tips. And I will click on apply view directions. And this will do as I asked for. So now let's go into design. My parameter for spacer, I like a little bit more cleansable, so 700 micron. And gingiva spacer, 100 is okay. Implant spacer, I will leave it at default. And 1.5 is okay. And margin 50 is okay. So I pretty much only change gingiva cleaning spacer into 700. And it's applied to every restoration because pretty much, gingiva is covering on each implants. So I press OK. And here's the main portion that we need to spend time on, which is the Biodraw. So it already gave me OK proposal. So on this particular case, I like to choose, this is when we choose on a posterior, and this is when we choose on anterior. I like to go anterior into tooth database, into merge, and choose form of, let's see, kind of shop around. And I will go particular this case for IT shape. And posterior, I'm going to choose them as merge as well. So here are my quick tools. When you click on numbers 8 on a positioning stage, I like to fine tune. I like to bring the arch little bit more outside, like that kind of arch form. So what I like to do is I'm gonna grab by pressing on Control and clicking each anterior teeth. I like to bring them out, which saves me time. Little bit more. Maybe make it a little bit longer. Again, I grab all these teeth by pressing on a control and clicking each teeth. I sort of fine-tune by moving arches, moving each teeth. It's pretty fair. Okay, so there's our Biodraw, and click Edit Restoration. The main advantage for me is that each individual teeth doesn't have to be on top of the implant site. As you see, like implant over here, okay. Now I have a little bit more room to work on the gingiva because the main key and main function of this type of case is creating good clear CJ line. So what I do is I click on shape tool and I kind of pull it down, and I always work on number 8 and 9 first. 7 and 10 seems pretty good, so I'm going to move on to the canines. And bicuspids and smooth out if there's any unnecessary defect or unnecessary grooves that we see. Just kind of smooth it out. So again, the beauty of gingiva, utilizing gingiva is that we could place each individual teeth into the place that wherever we like to place on, and that would be ease of doing because we have gingiva that saves all the connector height, connector strength, and positioning as well. For instance, I barely have contact here, and still I'm okay because I have gingiva that is contacting everything, and I don't worry too much. And here is a final proposal of your all-on-6 utilizing gingiva function. Maybe I could do a little bit of work over here for at least for 2 centrals. Make it better match, close the gap a little bit. Now that looks much better. And we move forward. Most of the design is ready. They're pretty ideal. So I'm gonna move forward and produce. And here we are. So I don't worry too much about these sharp angles over here of gingiva because after it is milled, I could easily adjust with my carbide, like right there. I'm gonna adjust. So at this point, what I'm gonna do, I'd like to export to inLab software cam. And it was exported successfully. So open the cam software and make sure. Before I go over the administration, undo the gingiva function and show different options. In the meantime, I like to if I export this case onto my desktop, make sure before I don't lose anything. Save on desktop. So also go on to the cam software and go to my cam software. In the meantime, it's gonna come in. Let's see. There we go. So I'm gonna mark on this guy and select the blank. I'm gonna use 25mm PMMA and move forward. And software will even place the bridge into the blank. I'm gonna cover on case without gingiva, so like to edit. Oh. So I'm gonna delete restorations. And I'm gonna go now new option without gingiva. Again, I'm gonna place Pontics. Implant connection, multi-unit abutment, anti-threading, and 800M. Go same with every restorations. And scan body type, in post Serona, in post for 2 connection, building M65. I'm gonna choose this one as zirconia. So we have already models ready. So I'm gonna jump onto the model. It looks good. Trim area looks good. So all I have to do is scan body. So here we are. We're doing edit jawline and arch. I really focus only on arch form, and we're gonna fix all this on Biodraw. So here's our model axis. Set model axis, and we want to make sure that arches are good. And as I mentioned, I had a better success in doing the length of good restoration, number 8, of proper space, so they gets me better proposal on the bio jaw. So we're gonna move on to the jaw line. I fine tune over here of proper arch form. Everything looks good. Now I jump onto scan body, and in order for me to save time, I pre-marked on each implant site. You notice the dots, purple dots. All right, now I'm gonna go on to edit baseline, where 3 seems good. Number 5. If I want to, I'd be able to edit the baselines. I mean, just the fact of utilizing gingiva mask gives me good proposal. Okay, 7 seems pretty good. Now move on to number 10. 12. Obviously, see the difference? His gingiva mask. It looks good. I just follow the gum line. Alright, move on to number 14. Obviously a little bit off, so I use gingiva mask. Alright, so there's the my number 14. On to define restoration axis, and you could look at the top view and facial view. And as I mentioned earlier, I like to create a little bit of facially. That's what I want. Perfect. Okay, so let's move on to the Biodraw. On occlusal milling offset, on all on 5 cases, all on 6 cases, I would like to leave it on 0. So it's more predictable for me. And strength is good. Gingiva depth, I like to leave it at 0. Gingiva pressure, I don't mind going a little bit heavier. Say about 150 to 200 micron. And a spacer, on a titanium cap, I like to leave it around 50 is fine. And I simply click apply for similar restoration elements. So it applies on 3, 5, 7, 10, 12, and 14. So I press OK. So now let's move on to morphology. So again, to have a better better comparison with the gingiva function, I'm gonna go ahead and choose the MERTS and IT shape, AFIT shape. Same as posterior to database, MERTS, and integral. Correct me if I'm pronouncing it right. So again, we're pretty good. We're already pretty good. I just have to position it a little bit towards more facial. So go on to the positioning. So as I mentioned earlier, that I like to, I'm gonna click on harmonic positioning. Okay, and adopted proposal, which doesn't make big difference because we don't have any opposing on this case. So let's set it one by one. It's just like if you're setting denture tooth digitally. Then click on space, smaller it a little bit. And just to let you know, on these all on 6 cases, more than 90% of the time, we're creating gingiva as well. So on this portion over here, later, after mill out, I would probably create gingiva like this, utilizing either pink porcelain or pink composite, just like that, sort of. So we could imagine what I mean by it is I need to lengthen it nicely so that we have rooms for pink composite or porcelain as well. All right, so let's move on to number 7 and 10. I like to place it right on top of the implant abutment, implant site. Front 4 anterior is always most important thing for me. All right, they look pretty straight. So now let's move on to the canines. They're slanted in too much, so number 11 looks pretty good. All right, how easy was that? And look at the full arch. Kind of look at the arch form one more time before I hit edit restoration button, which will give me final proposal. So that seems pretty darn close of what I want for final destination. Actually, let's make them a little bit smaller on the molars. Molar looks a little too large to me. So again, the quick button moving from move tool to the scale tool is clicking on the scale space button. You always want to kind of fine tune. All right, so here we go. Edit restorations. All right, so here's my proposal. As I expected. So I'm looking around the restorations, and most of the tool that I use here is it always comes up very nicely according to Biodraw. And what I would do is I would probably first I check my edit baseline, which saves me most of the times, where I like to extend it a little bit so it gives a little bit more, a lot more strength, especially on the connector. Yeah, same goes here. So in our designing, we always go from big picture to smaller detail. We created all the arch form in a good way, thanks to Biodraw function. Okay, I'm gonna get back to those area later. First, I like to focus on these pontic lines. And I sort of like the connector to be intersection area. So, hold on. Press edit on a connector. Now I have to click intersection and click on each connecting area. See how they're changing? It's going to make it into intersection connector. And press OK. Go back to design. See, they're gone. Nice. And I don't worry about it this area too much because I mentioned to you that my gingiva would be like this. Sort of. So I'm creating sort of an ideal profile situation. And let's look at the interproximal space. 17.94. I like to kind of get it up to like 20, but it is okay because I'm applying some. But let's see. Now let's see. It's 1962. Okay, just a little bit more. Just want to get it to like 20. It's 97. That's 20 right there. You got it. All right. Now another beautiful function of software 15 is that I don't need to sit there and click and wait for the restoration to move on. I mean, sometimes it's a little too fast. So 10 and 11 was 21, 11 and 20, 12 is 28, which is plenty. 12 and 13, so I gotta work on this guy a little bit, so I don't like any of step occlusion. So I fix that first. A little bit of push on the gingiva. Let's check the connector. 22, which is plenty now. And also on the molar, this guy is a little too much out. So I'm just going to use the move tool. And let's see now. I have 24 now on the connector. The area that I was looking at was this area, and I would click on that area to check the connector cross sections. And I personally prefer minimum 20 millimeters. So that's pretty much it for designing on all on 4 type screw retain bridges without gingiva functions. This type. Okay, now let's move on to the produce area. I like to utilize a display object, and I like to disguise a little bit. Actually, let's use a plus tool, just so that we can sleep at night. You're gonna be surprised when you work in a clinic side that how easy to control the gingiva is, as long as the patient is numbed. Our responsibility is to create the restoration so that they're gonna last. That's why we have all these tools. It takes us just a couple of seconds, couple of minutes. Sorry. All right, that's pretty fair. Okay, move back to produce the milling preview. There you are, all on 6 bridge. So I'm going to export it to the CAM software, and in very short time, I'd like to show on same screen between with the Gingiva function and without Gingiva function, goods and bads. So I move to my, let me fit it. So here we are, we're on CAM software. One is with Gingiva function, and I use this one for PMMA. And the other one, without Gingiva function, I put it on zirconia puck with a centering support bar. So talk about zirconia restorations. I basically do not like to change any of sprue, especially on the center bar. I just like to leave it as it is, as what software proposed to me. And I just had really better luck with this way. And sometimes I try to put like I felt insecure, so I would put something like 6 support bar, and I didn't have better result. So maybe to save your time, I wouldn't recommend to put any changes on the lingual side with the center bar, support bar area. So I would leave it as it is. Maybe I could delete maybe a couple of it on the interior. I just took out 2 and maybe these 2. That's what I would do. I wouldn't change any difference more. So underneath, this is how it looks like. It looks like this here, but they actually mill up to screw axis hole, so not to worry about it. And I personally, if you personally ask me what would be my go-to favorite technique, I would probably go without gingiva functions and do pink porcelain or composite on it. It's just, for me, it's just a little bit more predictable, because when you look at with the gingiva function, there's still some work to do for me to kind of smooth it out, and it's less predictable for me. But however, utilizing gingiva function, I have more freedom to place each tooth on any positions. I don't need to be really limited by the placement of implant. You see how number 3 and 4 implant position is right in between, and I'm still okay. So that's what good for gingiva functions. So I would probably need to cut back around this area to create a little bit more of a pink color. So I move it to the milling for PMMA on gingiva functions, and I can move this restoration into milling with zirconium, and I wouldn't change much. So again, my favorite materials on All-on 6 is definitely zirconium material for final restorations, and I would do without gingiva functions on zirconium. Just workflow is a lot smoother for me, and for me to apply with my my artistry on top of it after sinter. And always, more than most of the times, we do provide screw retain PMMA first before we move on to final prosthesis, which is zirconium, or whichever way you want to. So with PMMA material, I like to do with gingiva options and mill as it is. So there's PMMA with gingiva functions, and there's a zirconium without gingiva functions. Just to summarize, we went over administration on screw retain bridge, scanning with new scan post, multi-unit screw retain bridges, designing with and without gingiva functions, milling in CAM software, and material options. This was Shana CDT. Thank you for joining me on this wonderful Software 15. Please note I have courses coming up in February and throughout 2016 through DigiSmile and Sorona.